For this video, we will be discussing case 3 of integration by partial fraction decomposition. So for case 3, we have distinct quadratic factors. So this pertains to the denominator. Okay, so when our denominator contains a quadratic factor or quadratic factors. So the same steps will be applied. So first, we will factor completely the denominator. So in this case, we'll have this example, integral of x cubed minus 4 dx all over x cubed plus 2x squared plus 2x. Okay, so observing the denominator, factoring it completely, we will have a distinct linear factor of x. So let's try to see what will happen. So we'll have integral of x cubed minus 4 dx over x squared plus 2x plus 2. Okay, so as you can see, we can't factor the quadratic anymore. So we have x squared plus 2x plus 2, so this cannot be factored further. So therefore, our partial fractions will contain one fraction will contain a quadratic denominator. Okay, so let's try to resolve this into its partial fractions. So but first, let us observe if the numerator and then the denominator, let's observe their degrees. So we can see that they still have the same degree, right? X cubed and then in the numerator and then x cubed in the denominator. So therefore, so we can still divide this. So dividing x cubed minus 4 by x cubed plus 2x squared plus 2x. So we will have x cubed and then plus 0x squared plus 0x minus 4 divided by x cubed plus 2x squared plus 2x. Okay, so x cubed divided by x cubed, that is 1, and then 1 times x cubed, that is x cubed, 1 times 2x squared, so that's plus 2x squared, 1 times 2x plus 2x, and then subtract. So x cubed minus x cubed, that is 0. 0 minus 2x squared, that is negative 2x squared. 0 minus 2x, that's minus 2x. And then bring down negative 4 minus 4. So 2x, negative 2x squared divided by x cubed. So that cannot be. So therefore, this is our remainder. Okay. So therefore, we can write our integrand as integral of, we have quotient of 1 plus remainder over divisor. So our remainder is negative 2x squared minus 2x minus 4 over the denominator, which is the divisor. Then we can express it in factored form. So x times x squared plus 2x plus 2. Okay, dx. Okay, so therefore, what we need to resolve into partial fractions is this. Okay, so by partial fractions, so let's copy. By partial fraction decomposition, so we have negative 2x squared minus 2x minus 4, okay, this one, divided over x times x squared plus 2x plus 2. Okay, so that is equal to So we have a linear factor. So a over x plus. So for this one, so we will have a denominator of a quadratic denominator, right? So you have x squared plus 2x plus 2. Okay, so ordinarily our numerator, okay, should be linear, right? So we can write it as bx plus c. Okay, but since we are trying to integrate this, then we will write the numerator, we will write the linear numerator in such a way that we can integrate it later. Okay, it will be easier for us to integrate later. So instead of writing bx plus c, so we will replace x with the derivative of the denominator. Okay, so again our numerator here should have been bx plus c. Okay, so notice this is linear, bx plus c. Okay, but again we will replace x with the derivative of the denominator so that later on it will be easier for us to integrate it using logarithmic. Okay, so instead of writing x, so we write the derivative of the denominator. So b, so instead of x, so what is the derivative of the denominator with respect to x? So that is 2x plus 2. Okay, and then plus c. So in that form, it is still linear. The numerator is still linear, but later on, you will appreciate this because it will be easier for us to integrate. So the same process, so multiplying this, multiplying the denominator, cross multiplying it, so we will have negative 2x squared minus 2x minus 4 is equal to, so multiplying this with this, so it will cancel x, so what will remain is a times x squared plus 2x plus 2. Okay, and then again doing it on the second term, so it will cancel x squared plus 2x plus 2, and then what will remain is x. So therefore we will have b times b times 2x plus 2, okay, plus c multiplied by x. Okay, so if we distribute x, so we will have negative 2x squared minus 2x minus 4 is equal to a times x squared plus 2x plus 2, okay, plus, so distributing x here, so it will become b times 2x squared plus 2x, okay, plus cx. So from there we can now solve for the numerical coefficients a, b, and c. Okay, so since we have a linear factor, then we can substitute a number so that we can solve for one of the unknowns. So here we have x and x squared plus 2x plus 2, so we can equate x is equal to 0. So letting x is equal to 0, so we will have for this 0 minus 0, and then we will have here minus 4 is equal to a times 0 plus 0 plus 2 plus b times, substituting here, this will become 0, and then this one will become 0 plus c multiplied by 0. Okay, so you can eliminate b and c, so what will remain is negative 4 is equal to equal to 2a. Okay, so dividing both sides by 2, so we'll get a as negative 2. Okay, so next is, since we don't have any more values for x to use, then we will now proceed with equating coefficients of similar terms. So equate coefficients of similar terms for x squared from here, for x squared. So on the left side, negative 2 is equal to, on the right side, a plus b. Oh, sorry, a plus 2b. Okay, because if you distribute b, then it will become 2bx squared. So therefore, the coefficient of x squared is 2b. So a plus 2b. Okay, so since we know that a is equal to negative 2, then negative 2 is equal to negative 2 is equal to negative 2. A is equal to negative 2 plus 2b. If we transpose negative 2 on the other side, therefore it will become 0. So 2b is equal to 0, then therefore b is equal to 0. Okay, so sorry, another one. So x, coefficients of x. So we'll have negative 2 for coefficient of x. Here we have plus 2a is equal to 2a. For b, plus 2b, sorry, and then plus c. So since we know that a is equal to negative 2, and then b is equal to 0, then plus c. So solving for c here, c will be equal to, we have, so it will become negative 4, transposing, so c is equal to positive 2. Okay, so therefore we can say that negative 2x squared, from 2x squared minus 2x minus 4 over x times x squared plus 2x plus 2 is equal to negative a over x. So negative a, it's a over x, so therefore it's negative 2 over x. So negative 2 over x plus, we know that b is equal to 0, so therefore only c will remain. So c over, where c is equal to 2, so over, plus 2 over x squared plus 2x plus 2. Okay, so to check if that is right, so all you need to do is add the 2. Okay, so if we add them, so let's just try to add them. So it will become, so least common multiple of the denominators is their product. So x times x squared plus 2x plus 2, then this one divided by this multiplied by the numerator, so it will become negative 2 times x squared plus 2x plus 2, and then plus this one divided by this, so what will remain is x, and then multiplied by the numerator, so we will have 2x. So if we simplify this, so this will become negative 2x squared minus 4x minus 4, and then plus 2x over x times x squared plus 2x plus 2. Okay, so as you can see, 4x plus 2x, so this will become 2x, so practically the same. Okay, so therefore our integral will now become, sorry, so from this one, okay, so therefore the integral of uh, 1 plus negative 2x squared minus 2x minus 4 over x times x squared plus 2x plus 2, okay, dx. So this is now equal to integral of 1 plus the partial fractions. So where are those? So this one. So plus negative 2 over x and plus 2 over x squared plus 2x plus 2. Okay, dx. So from this one, okay, from the given, okay, so performing division and partial fractions, so this one is equivalent to this one. Okay, so now those terms can be integrated. So let us distribute the integral sign and dx, and then take the numerical coefficients outside the integral sign. So it will become, so for 1 it will become integral of dx, then this one will become, take out the negative 2, so minus 2 integral of, so multiply dx, so this will become dx over x plus 2 integral of dx over the quadratic denominator. Okay, so but you can rewrite the denominator as by completing the square, so x squared plus 2x plus 2. Okay, so rewriting it here, so x squared plus 2x plus 2, so completing the square, the last term should be positive 1, so x squared plus 2x plus 1. Okay, so review your completing the square, so x squared plus 2x plus 1, okay, and then plus 2, and then since, so this 2 here, so since we added 1, therefore we must subtract 1, so therefore this will become x plus 1 squared plus 1. Okay, so if we rewrite this in this form, then we can solve this using arctangent. So x plus 1 squared plus 1 squared. Okay, so therefore integral of dx is x minus 2, integral of dx over x is ln of x plus 2 times integral of this, so we have here u is x plus 1 is du is a complete differential of u, so therefore 1 over a arctan u over a plus c, so we have 1 over a, 1 over 1 arctan of u over a, arctan of x plus 1 over 1 plus c. Okay, so all you need to remember, if you have quadratic factor, distinct quadratic factors, so there is an arctangent. Okay, and then in this case we don't have the ln, natural logarithm, with this denominator, okay, the x squared plus 2x plus 2. So in this case we don't have that term because we have solved b is equal to 0. So but those two most of the time are the integrals, okay, of the fractions with the quadratic denominator. So we will have x minus 2 ln of x plus 2 arctan of x plus 1 plus c. Okay, so that's it. Okay, so for our second example, so we have integral of x plus 65 dx all over x cubed plus x squared plus x minus 39. So first, let's check if this is already a proper fraction. So the degree of the numerator is 1, the degree of the denominator is 3, so therefore, it's already it's already a proper fraction. So therefore, we don't need to divide. So we will then proceed to partial fraction decomposition. So first, we need to factor the denominator. Okay, so how do we factor the denominator? So maybe we can use the remainder theorem. Okay, so we will substitute values for x, and where this expression should be 0, okay, if we find the right factor. Okay, so let's say, for example, so let's say positive 1. So if we have positive 1, okay, so this is still factoring. So at x is equal to 1, so we will have x cubed plus x squared plus x, so this 1 cubed plus 1 squared plus 1 minus 39. So that's not equal to 0. How about x is equal to 2? So we have 2 cubed plus 2 squared plus plus 2 minus 39. So this is 8 plus 4, 12, 14. So still not equal to 0. How about if x is equal to 3? So we will have 3 squared plus 3 cubed plus 3 squared plus 3 minus 39. So this is 27 plus 9, 36 plus 3, 39 minus 39. This is equal to 0. So therefore, we have x minus 3 is a factor. Okay, so therefore we can simply just divide this. So divide x cubed plus x squared plus x minus 39 by x minus 3. So x cubed plus x squared plus x minus 39 divided by x minus 3. So x cubed divided by x, so that is x squared. X squared times x, that is x cubed. X squared times negative 3x, so that's negative 3x squared, and then subtract. So we will have x cubed minus x cubed, we have 0. 1 minus negative 3, so that is positive 4x squared. Bring down x. 4x squared divided by x, so we have plus 4x. Multiply 4x times x, 4x squared. 4x times negative 3, that's minus 12x, and then subtract again. So 4 minus 4, 0. 1 minus negative 12, so we have plus 13x. And then bring down minus 39. So 13x divided by x. So we have plus 13. And then 13 times x. So we have 13x. 13 times negative 3. So we have negative 39. Subtract again. So it's 0. So therefore, So therefore, x cubed plus x squared plus x minus 39 is equal to x minus 3 times x squared plus 4x plus 13. So therefore, we can rewrite the integral. So the integral of x plus 65 dx is equal to x minus 3 multiplied by x squared plus 4x plus 13. Okay, so sorry. Okay. So, unfortunately, we can't factor this further because as you can see, 13 is a prime number. So, its factors are 1 and 13 only. Okay, so we have no way to factor this. So, therefore, we will resolve this into a partial fraction where another denominator is a quadratic function. So, by partial fractions, x plus 65 over x minus 3 times x squared plus 4x plus 13 is equal to okay, so the first partial fraction will have a denominator of x minus 3. The second will have a denominator of x squared plus 4x plus 3. Okay, so the numerator of x minus 3, so since x minus 3 is linear, therefore its numerator is a constant. And then since this is quadratic, the denominator is quadratic, therefore the numerator must be linear. Okay, but we will write it in such a way that we can integrate it easier later. So therefore, the x term in the linear expression will be replaced by the derivative of x squared plus 4x. So b times, so instead of writing x, we'll write the derivative of the denominator. It's 2x plus 4. And then plus c. Okay, so next, cross multiplying. So therefore, x plus 65 is equal to a. So if you cross multiply this, we will cancel x minus 3. Then what will remain is x squared plus 4x plus 3. Okay, plus b. And then if we cross multiply this, so it will cancel x squared plus 4x plus 3. Therefore, what will remain is this, the numerator multiplied by x minus 3. So b times 2x plus 4 plus c times x minus 3. So let's distribute. So x plus 65 is equal to a times x squared plus 4x plus 3. Sorry, that's plus 13. Okay, that's plus 13. Plus 13, plus 13, plus 13. This is plus 13. So I'm so sorry. So plus 13 plus b times 2x plus 4 times x minus 3 plus c times x minus 3. Okay, so let's distribute this for later if we need to equate coefficients of similar terms. So x plus 65 is equal to a x squared plus 4x plus 13 plus b times, so 2x times x, that is 2x squared, 2x times negative 3, that is negative 6x, plus 4 times x, 4x, so negative 6x plus 4x, so that is minus 2x, and then 4 times negative 13, negative 4 times negative 3, that is minus 12. Okay, plus c times x minus 3. Okay, so to solve for a, b, and c, then we will need, so we can substitute a value for x. So as we can see, it will become 0 if we substitute x is equal to positive 3. Okay, so let x is equal to 3. Then this will become, so we can substitute it here in the second one, okay, because we have here the x minus 3 and x minus 3, so later on this will become 0. So 3 plus 65 is equal to, substituting here, so a times 3 squared plus 4 times 3 plus 13 plus, so as you can see, the b, coefficient b, the unknown b, will have a coefficient of 3 minus 3, which is equal to 0. So therefore, b will now become 0. And also with this third term. So therefore, we can solve directly for a. So 65 times 3, that is 68, is equal to 9 plus 12 plus 13. So 9 plus 12, that's 21, plus 13, sorry, 9 plus 12, that is 21. 21 plus 13, that is 34. So dividing both sides by 34, I think a is equal to 2. Okay, so next is, since we don't have any numbers to, other numbers to, sorry, so since we don't have other numbers to substitute, so we can equate coefficients of similar terms already. So equating coefficients of similar terms, so we can equate x squared. So on the left side, it's 0, okay, is equal to coefficient of x squared. We have here on the right side a plus, we have 2b. Okay, so since a is equal to 2, then we will have 0 is equal to 2 plus 2b. So solving for b, so we can see that if we transpose 2, it will become negative 2, dividing both sides by negative 2, so therefore b is equal to negative 1. How about for x? So x, we have on the left side, we have 1 is equal to 4a minus 2b plus c. Okay, so substituting values for a and b, so 1 is equal to 4 times a is equal to 2 minus 2 times b is what? B is negative 1 plus c. So it will become 8 plus 2, that is 10, transposing on the other side, so we will have c is equal to negative 9. Okay, so therefore, rewriting our integrand, okay, so our integrand, which is back to the given, this one, so the integral of x plus 65 dx over x cubed plus x squared plus x minus 39 is equal to the integral of this now, this, okay, so the partial fraction, so a over x minus 3, where a is 2, so therefore 2 over sorry, 2 over x minus 3. Okay, plus, we have for b. b is negative 1, right? So b is equal to negative 1. So negative 1 times 2x plus 4. So negative 2x plus 4 plus our c is negative 9. So minus 9 over x squared plus 4x plus 13. Okay, and then dx. Okay, so the next thing that we're gonna do is we will separate this one. Okay, so this will become integral of 2 over x minus 3 minus, we have 2x plus 4 over x squared plus 4x plus 13. Okay, minus 9 over the same, 9 over x squared plus 4x plus 13. Okay, dx. So next we can distribute the integral sign and then write the numerical coefficients outside the integral sign. So we will have 2 integral of dx over x minus 3 minus integral of 2x plus 4 dx over x squared plus 4x plus 13. Okay, minus 9 integral of so we know that our third term can be integrated using inverse trigonometric function. So therefore we will arrange this one. Okay, rewriting this 4x plus x squared plus 4x plus 13. Okay, so that it will become in the form of the integral of arctangent. So recall that the integral of du over a squared plus u squared is equal to 1 over a arctan of u over a plus c. Okay, so now we can complete the square here. So we have here, so I'll just rewrite it on another sheet of paper. So x cubed plus x squared plus 4x, so completing the square. So the third term should be second term divided by 2 divided by the square root of the first term and then squared. So that will be 4x over 2 square root of x squared and then squared. So this will be 4x over 2x. So therefore that's equal to 2. So therefore the last term is 4. So plus 4 and then plus, we have 13. And since you added 4 in here, so therefore we must also subtract 4. Okay, so this will now become x plus 2 squared plus 9, or 9 is 3 squared. So therefore this can be written as x plus 2 squared plus 3 squared dx. Okay, so again in the formula, so we have our u as x plus 2, its du is dx. So the numerator is the complete differential of u, so therefore we are good to go. So we can integrate this. We can now integrate this. So 2 integral of dx over x minus 3, that is 2 ln of x minus 3. Okay, minus, this one is also natural logarithm. The numerator is the complete differential of the denominator, therefore it's also ln of x squared plus 4x plus 13. Okay, so minus numerical coefficient 9 times integral of this based on the formula is 1 over a arctan of u over a. So therefore it's 1/3 arctan of x plus 2 over 3. Okay, plus c. So simplifying, so this will now become 2 ln of x minus 3 minus ln of x squared plus 4x plus 13 minus 3 arctan of x plus 2 over 3 plus c. Okay, so that's quite a long process again. Okay, but the secret is you just do it step by step. Okay, and then remember, if we have a quadratic factor, okay, so the first term will be can be integrated using the natural logarithm, and then the second, here we can solve that using inverse trigonometric. Okay, just like we did here. Okay, so thank you for watching, and I hope you have understood the problem. Okay, and then thank you, and then see you in the next video. Good luck.